Hi everyone, I'm Stephanie Peer and welcome to the Salt-Tea Science Podcast. And I'm super excited that you could join us for another exciting episode because this week we'll be discussing the winter solstice as observed in the Northern Hemisphere. Why? Because it's happening tomorrow, Saturday, December 21st at 11:19 p.m. Eastern Time. And of course, to all of my Australian listeners, you're going to be experiencing the summer solstice. But for the sake of simplicity, we'll be focusing just on the Northern Hemisphere winter solstice in this episode. Alright, so let's first ask the question, what is the winter solstice? Well, we define the Northern Hemisphere's winter solstice as being the astronomical moment when the sun reaches the Tropic of Capricorn, and that's about at a latitude of 23.5 degrees south. But for those of us in the Northern Hemisphere, we may know the winter solstice better as the time of the year where we experience the shortest day and the longest night, in terms of daylight, of course. And fun fact, the winter solstice marks the official start of winter. And for those of you who love the snow and winter, this is the perfect time of year for you. Alright, so next question. When is the winter solstice? Well, the actual time in which the winter solstice can occur can vary from year to year, such as on some years it's December 20th, or on other years it's the 21st or the 22nd or even the 23rd. But like I said earlier, this year, 2019, the winter solstice occurs on Saturday, December 21st at 11:19 p.m. Eastern Time. Alright, so the next question I know you're just dying to ask is, what does the word solstice actually mean? Well, the term solstice actually comes from two Latin words, meaning the sun and to stand still. And this is because during the solstice, the angle between the sun's rays and the plane of the Earth's equator appears to stand still. Alright, so now for the really big question. What does the winter solstice mean for our oceans? Well, just like in the 2019 fall equinox episode, let's answer this question a priori, which means that we're going to answer the question based on our current knowledge of the ocean by means of a theoretical deduction, rather than from experimental or observational experiences. Alright, so we know that the winter solstice means that we're going to have the shortest amount of daylight hours available, especially the further north we go, and the North Pole has barely seen any sunlight, if any at all, since early October, at least according to the National Ocean and Atmospheric Administration, also known as NOAA. Okay, and we also know that while the sun itself isn't changing and it's still emitting the same amount of solar radiation, the amount of insolation, or radiation that actually hits the surface of the ocean, is drastically reduced. So there's not going to be as much solar radiation energy reaching the surface of the water, meaning that there's less energy that is being converted to heat at the surface of the oceans in the Northern Hemisphere. So because there's less energy being converted to heat energy, we would expect that the oceans would be getting colder with less solar energy. But quick reminder, because water has a high heat capacity, we won't necessarily see a drastic change in temperature from just one day of very little sunlight. But since the fall equinox, the amount of light in the Northern Hemisphere has been less and less each day. So the water has been gradually losing more and more heat energy, making the water temperatures colder and colder. Which, even here in Virginia, the water has definitely been getting colder and colder each day, and will only get colder as we progress through winter. And we know that when the temperature of the water starts to get colder, the density of the water increases. And as the density of the water increases, it will become heavier and will start to sink below parcels of water that are less dense. And we also know that as seawater starts to get colder, once it reaches a temperature of -2 degrees Celsius or 28.4 degrees Fahrenheit, the water will start to freeze and sea ice will begin to form. And of course, we can't forget that sea ice actually removes fresh water molecules from the water, but leaves all the sea salts behind, making the surrounding water even saltier, which then also makes all the surrounding water even denser, which then makes it even more likely to sink below the less dense water. And of course, if we're looking at the North Atlantic Ocean, we would see that this cold, dense, extra salty water begins its journey on the global ocean conveyor belt. And even though we haven't discussed it as its own episode yet, we've talked a lot about photosynthesis. and that plants need sunlight in order to grow and to photosynthesize. And photosynthesis produces oxygen, which allows fish and other marine creatures to breathe. So with little to no sunlight on the winter solstice, we know that the biologically produced oxygen, which is a non-conservative element by the way, will not have as high of a concentration on the winter solstice as it would on, say, the summer solstice. And then we would also expect that other non-conservative elements that plants use would also be at higher concentrations because plants are just not using them as much right now. But on the other hand, other marine organisms and critters are releasing them in different biological processes like respiration. And finally, with colder water temperatures and less photosynthesis, many marine organisms and fish will also be preparing for winter conditions by either going into their version of hibernation or migrating south to warmer waters. Alright, so now it's time for our 1-minute summary. In this episode, we took a quick look at the winter solstice in the Northern Hemisphere, which is going to occur this year, 2019, on Saturday, December 21st at 11:19 p.m. Eastern Time Zone. And the winter solstice is the shortest day and the longest night for those of us in the Northern Hemisphere. And in this episode, we answered the question, what does the winter solstice mean to our oceans? And we answered it a priori, meaning based on theoretical deduction. And we looked at the ocean in terms of solar radiation, temperature, density, as well as with respects to non-conservative elements. And finally, we discussed how some marine organisms are undergoing their version of hibernation or traveling to warmer waters for the winter, even right now. And that's the end of our 1-minute summary. And before I close this episode, I just want to remind us all that our next listeners episode is coming up very soon. So if you have a great oceany or water-related story that you're willing to share with us and have it read aloud on air, email me at saltysciencepodcast@gmail.com. I've already received some great stories that I just can't wait to share with you. And just to let you know, the deadline to submit a story for this upcoming listeners episode is Saturday, January 25th at the stroke of midnight. But you don't have to wait until then to submit your story. You can email me anytime between now and then. And finally, I just want to say that if you do have a story you want to share, but you want to remain anonymous or prefer that I use a specific username or alias, just make sure to let me know that in the email, and I will be more than happy to accommodate. Alright, so as I say goodbye, don't forget to do at least one thing this week to help keep our oceans beautiful and clean, and to always stay salty. Thank you for listening to Salt-Tea Science. But guess what? You don't have to let the fun end here. Go to www.saltysciencepodcast.weebly.com, where I've posted some cool videos, my study notes, and some really neat experiments that you can try at home. And if you want to follow along with my own research, you can follow me on Instagram. User handle Teps Adventure. That's TEPS Adventure. All Salt-Tea Science episodes are available on iTunes, Spotify, Google Podcast, and YouTube, plus a number of other podcasting apps. If you like the show, please rate, review, and subscribe on iTunes, as this is the best way to spread the word about this podcast. Salt-Tea Science is listener supported, so if you would like to show your support, visit our Patreon page at www.patreon.com/Salt-Tea Science, where you can either make a one-time donation of any amount or join the Salt-Tea Science crew for as little as $1 a month. So visit the Salt-Tea Science Patreon and sign up today.